Welcome to the Nemeth Refresher webinar for TVIs. My name is Julie Sumwalt. I'm the Braille specialist at the Wisconsin Center for the Blind and Visually Impaired under the Department of Public Instruction for Wisconsin. The Wisconsin policy for Braille math is that we are sticking with Nemeth with UEB. So the terminology there is UEB with Nemeth. Standardized tests for Wisconsin are in UEB with Nemeth. Be aware that other states, however, may use UEB for technical material. That's called UEB technical. The United States is the only English-speaking nation to use Nemeth. The official rulebook for Nemeth is the Nemeth Braille Code for Mathematics and Science Notation, yes, 1972 revision. There are numerous updates and addenda, of course, since then, and you can find those on the Braille Authority of North America, or BANA, website, which is brailleauthority.org. There is a UEB version of the Nemeth Code coming along, but it might be a while. The Nemeth Code for Braille Mathematics and Science Notation 1972 revision is abbreviated NC in this presentation. All references are to NC unless otherwise stated. You can find the Nemeth Code book on the BANA website, as I said, and you go up there on the home page. Then on the left, there's a red menu, and you want code books and guidelines. So click that. Once you're on the code books and guidelines site, then there's a list of links, and you want to go down to Nemeth Code. From there, you can download all of the code books and revisions and addendums that you need. You can sign up for the BANA Announce listserv to get all the news from BANA on the Contact Us page. That will give you announcements about new decisions on rules and guidelines. Mostly it will tell you about BANA meetings that happen twice a year. So you will not get a whole bunch of emails from signing up for this listserv. You'll only get a few. That BANA announced listserv is how I found out about guidance for transcription using the Nemeth Code within UEB contexts. That's important if you are going to be using Nemeth Code with UEB. There's also a new document for graphing calculator guidelines. There's even a provisional guidance for chemistry notation using Nemeth in UEB contexts. So to reiterate, you go to the BANA website, brailleauthority.org, for any rules, guidelines, and updates. From there, you choose code books and guidelines from the menu, and then click on the link for the Nemeth Code in the list. That's where you will find the two major documents that you need now, the Nemeth Braille Code for Mathematics and Science Notation 1972 revision. Be aware that in 1972 there was no UEB, so that document is in the old code, which is EBAE. That stands for English Braille American Edition. You will also want guidance for transcription using the Nemeth Code within UEB context. That will help give you guidelines for incorporating Nemeth into UEB. There are some other Nemeth documents that are not necessarily, well, they're offshoots of the Braille Code. So the code books are your primary source. You may also be interested in these others that I have listed here. There are Nemeth reference sheets from National Braille Press. There's another Nemeth Code reference sheet for basic mathematics from APH, American Printing House. If you're interested in learning to become a certified Nemeth transcriber, You can find an Introduction to Braille Mathematics from the National Federation of the Blind, or NFB. Be aware that, again, that course is based on the old code EBAE. There is a provisional lesson manual that incorporates UEB, also from NFB, and you can find that at the link I have posted here. Two other documents that you may need if you're going to be doing a lot of transcribing Nemeth. One is Guidelines and Standards for Tactile Graphics from the BANA website. Also, again, BANA is a source for all the code books and guidebooks. So if there is a new document, as I mentioned, for graphing calculator guidelines. Another organization, the National Braille Association, or NBA, has a discussion forum for it's called Ask an Expert. That is found on nationalbraille.org. Go to that site, and then at the top, there's a tab called What We Do. If you click that, then you can view the questions and answers. Anyone can do that. You need to be a member, however, to open any attachment or to post your own questions, which you can do if you are a member at $50 each year. Within that larger Ask an Expert forum, there are 10 smaller forums, including UEB, formats, Nemeth, foreign language, and professional resources. Professionals being TVIs and transcribers, among others. Once you post a question, then it is answered by an expert in the field. NBA also has a number of webinars. Again, anyone can watch the live webinars. You need to be a member, however, if you want to watch any recorded and archived webinars. These webinars are usually about 15 minutes. There are longer paid webinars available. Those are usually about an hour and a half. Topics for those webinars include UEB, formatting, Nemeth, UEB technical, music, and foreign language. You can sign up for the NBA blog to receive announcements about dates and topics for the live webinars if you're interested. A side note about chemistry, there is a separate code for chemistry, and the official rulebook for that is Braille Code for Chemical Notation 1997. It's based on the Nemeth Code and has many of the same principles, but there are differences. So if you are transcribing chemistry at all, you will need that code book. It is based on the former code EBAE because it's from 1997, but there is a UEB version of the chemical code in the works, but ready yet. If you want that, you again go to the BANA website and get the chemistry code book under Nemeth Code. There is, however, a provisional guidance for chemistry notation using Nemeth in UEB contexts. That means that there will be an official final document sometime in the future. A quick word about formatting. The Rule 25 in the Nemeth Code covers all the formatting in Nemeth. There are some differences from basic literary formatting. You can also find a summary of Nemeth formatting in Appendix C of the Provisional Lesson Manual, which is in UEB context. And you can download that at the link I have up on the screen there. If Nemeth is used at all in a transcription, then the entire document is formatted according to Nemeth format rules, even the UEB text. So an example, directions and displayed material are different in Nemeth than they are in UEB literary. If you need to brush up on basic Braille formatting, there are documents, again, on the BANA website. One, you're probably not going to use very much. There's Braille Formats, Principles of Print to Braille Transcription 2011 that aligns with the old code EBAE. do not use that if you are using UEB. The updated version is Braille Formats, Principles of Print to Braille Transcription 2016, and that does align with UEB. You can find that again on the BANA website. You cannot use the 2011 formatting lines with UEB, nor can you use the new 2016 version with the old code EBAE. The two do not mix. So depending on the code that you're using, you will want to use the correct Braille formatting guideline document. A note about code switch indicators in case you've heard about those. Examples in this presentation that show only Nemeth do not use the code switch indicators. Code switch indicators should be used in actual practice when in UEB context. So if there's text around them, you would use the code switch indicators. I will be talking about code switch indicators later in the presentation. In part 2, I believe it is. Okay, Nemeth numerals are the basics of the Nemeth code. It's the foundation. And if you know anything at all about Nemeth, usually people do know that the numerals in Nemeth are dropped in the cell. The numeric indicator is the same in UEB as it is in Nemeth, so no change there. The Nemeth comma is .6. So for mathematical expressions, if you need a comma after them, use .6. A comma that follows words in the is the literary comma, which is the familiar .2. So if you have 2 plus 2 in mathematical notation followed by a comma, you would use .6. But if you have the words in literary context, then you would use the words 2 plus 2 and the literary .2 comma. There is something called the English letter indicator in the Nemeth code, and it works much like the grade 1 indicator in UEB. It looks exactly the same. There are lots of rules about using it or not using it. I'm not going to cover that in this webinar, but you can look them up in Rule 4 of the Nemeth code. So the English letter indicator is just like the grade 1 indicator using dots 5, 6, but their usage is different. Signs of operation are also fundamental to Nemeth code. Common signs of operation are the plus, minus, multiplication cross, the multiplication dot, and division, as shown with a horizontal line and a dot above and below. So we just looked at signs of operation. Now let's look at signs of comparison. Common signs of comparison are the equals sign, greater than, less than, ratio, and proportion signs. Some other common symbols would be the dollar symbol, which is the same as UEB, but different rules. The degree symbol, here I have shown the first sol as the superscript indicator, which is always included with the degree symbol, but the degree symbol itself is dots 4, 6, 1, 6. And then I'm showing it along with the superscript indicator of dots 4, 5. There is something called a symbol of omission in Nemeth that represents a blank space, question mark, all sorts of things in print that need to be shown with a single cell. The decimal point in Nemeth is 4.6. That's different than UEB, as is the percent symbol, which in Nemeth is dots 4 and then 3, 4, 5, 6. A note about terminology in the Nemeth code, which always goose me up, but I need to say that a sign is in print, a symbol is in Braille. So the Nemeth code talks about Braille symbols and print signs. Appendix B lists all the Nemeth symbols in Braille order. A word about early math. Counting, sorting, and other beginning math concepts must be shown with tactile graphics, not Braille symbols. That's because young students like that are still learning that dots mean words, letters, and sentences. So to use those same dot configurations to represent visual activities would be very confusing. So we need to use something that's completely different, namely tactile graphics that feel completely different than Braille symbols. There are guidelines for all those tactile graphics covering such topics as counting shapes, graphs, thermometers, and rulers. Again, you go to the BANA website for that code book and get guidelines and standards for tactile graphics. In that document, there are guidelines for number lines, both for early grades and later grade levels. Because again, in early grades, we can't use dots to represent number lines, but in later grades, it's okay to use them. Another quick word about another topic, computer notation. Computer Braille code was based on Nemeth Code, but computer Braille code is no more. If you need to show something like address, what email address, a website URL, or file name, then you're going to use contracted UEB for that. You can find those rules in the Rules for Unified English Braille, section 10.12.3. You are also going to use UEB, but in grade 1 for computer programming, such as JavaScript or C++, when they appear on separate lines, as well as any nearby programming codes. You can find that in another document called Guidelines for Technical Material. That is still UEB code, it's just bound in a separate volume. I also want to say something about the 5-step rule in Nemeth, because it's the question I get asked the most when talking about Nemeth. So I want to talk about that first. 5-step rule is for modifications. And modifications in Nemeth are mathematical symbols that are printed directly above or below an expression. Those modifications are shown with this 5-step rule. Here is an example. You might have the capital letters AB with a right pointing arrow directly above them, meaning Ray AB. In that case, you need 5 components to show that arrow. First, you need the multi-purpose indicator, which is .5, to say that this next expression is going to have a modifier. Then you have the expression being modified. In this case, it's capital A, capital B. In Nemeth, you capitalize each letter individually. Then we need to show either directly over or directly under. In this case, directly over, because that arrow is directly over AB. Then show what the modifier is. In this case, it's a right pointing arrow, which can be contracted in Nemeth as shown. The 5th part of the 5-step rule is to terminate the whole modification, and you use that with the termination indicator. So 5 components to the 5-step rule. There are contracted forms for just a simple line above or below a single digit or letter. If a line is shown above a single digit or letter, that is in the original Nemeth Code, section 86B. Later, it was added with an update, 86C, for a line directly below a single digit or letter. For that, you use the contracted form, which looks like SHWH, but it's not. It's dots 146, 156. If there are 2 or more consecutive digits or letters with a line above or below, that's not a single digit or letter anymore, so you need to follow that 5-step rule that we just talked about. You cannot use the contracted form for each digit or letter. However, if multiple non-consecutive digits or letters have a line above or below them, it seems reasonable to use the contracted forms. There's no rule about that. It just seems like the thing to do. And it doesn't seem to cause confusion. So in the numbers shown here, I have 5,374,218. The 3 and 2 in this case are underlined. They are not next to each other. So it would seem okay to use the contracted form for a line directly under those digits. So we have our number sign 5 in the lower cell, Nemeth comma dot 6, 3, then we're going to use the contracted form for the line below. So directly below some indicator there, that's 1, 4, 6. Then the line indicator, that's 1, 5, 6. Continue on with the numbers, 7, 4, comma, 2 is underlined. So again, use the contracted form for the line directly below. Then continue on with the number 1, 8. The next few slides, I just put in the Nemeth Code table of contents. I'm not going to read through it. I just want to give you kind of a scope of what is covered in the Nemeth Code in as a easy reference here, as opposed to looking into the Nemeth Code book itself. But of course, you should go to the Nemeth Code book. So here is the table of contents. It starts off with an orientation, which is important but often skipped over. Notice the Nemeth Code divides things up into rules shown with capital Roman numerals. It's a very long table of contents. It's a very large document. It finishes with 2 appendices. Appendix A shows what various combinations of type form indicators like bold and italics, alphabetic indicators like Greek letters, and capitalization indicators. So mixing and matching those, that's what Appendix A is all about there. Followed by Appendix B, which has the whole list of Braille symbols. It's quite large, and they are in Braille order. Following that is just a regular index for the codebook. Okay, jumping right into spatial arrangements. This is actually shown last is introduced last for would-be Nemeth transcribers because it is so complicated. However, it's usually used in elementary grade levels. So it's kind of a quandary. So I'm just going to go right into it and talk about spatial arrangements first. Spatial arrangements are vertical arrangements of mathematical equations and computations. They include addition, subtraction, multiplication, and division. The big thing about spatial arrangements is that no numeric indicator is used in those kinds of computations. The next big thing about spatial arrangements is that a blank line must be before and after a spatial arrangement of any kind. So let's talk about addition and subtraction first. For addition and subtraction spatial problems, meaning vertical, we align like under like. That means digits go under digits, commas go under commas, decimal points go under decimal points, fractions under fractions, abbreviations under abbreviations, signs of operation under signs of operation, and signs of comparison under signs of comparison. Everything must line up. That means that any plus, minus, or dollar symbols, if they are present in print, are placed to the left of the widest column above the separation line. I'll show you that in a moment. That's a lot of words. The separation line must be 1 cell longer on either end than the overall width of the arrangement. In other words, it must stick out on either side. Here is an addition problem. It's vertical, so that means it's spatial. So the first thing to note again is no numeric indicators, and there has to be a blank line above and below. It doesn't have room on the screen. So we have 20 plus 2 equals 24. In Braille, we have 20. It's 2 digits wide. 2 is only 1 digit wide. So line up the ones place, line up the tens place. There is nothing in the tens place for before the 2 that we're adding. So 20, then 2, that plus sign that's there in print needs to be 1 cell to the left of the widest component above the separation line. In this case, it's 20, 2 digits long. So we have to have the ones digits lined up and the tens place lined up. And that plus sign, it needs to be out of the way. So we're placing that 1 cell to the left of the whole arrangement above the separation line, which, as you can see, is a row of cells, that's 2, 5. They stick out 1 cell on the left and 1 cell on the right. Then we have our answer 24. And because that plus sign is moved out of the way, we can vertically place our fingers 0 to 4 in the ones place, and then the tens place, 2, nothing equals 2. What about carried numbers? Carried numbers are indicated with a carried number indicator, which is the length of the separation line. The carried numbers are placed above the carried number indicator. So again, no numeric indicator in spatial arrangements. There would be a blank line before and after. I just don't have room to show it on the screen. So here's a problem: 365 plus 239 carried numbers in the tens place and the hundreds place equals, with that separation line, 604. So in Braille, we have line up our problem first, which is 365 plus 239. They both have 3 digits, so that plus sign can be snugged up against 239, but still placed 1 cell to the left of the widest arrangement, which is both 365 and 239. So that is out of the way. Then our separation line, that row of dots, 2, 5, sticking out on the 1 cell on the left and 1 cell on the right. The answer, 604. So all the ones place line up, all the tens places line up, all the 100s places line up. Then we have the carried number indicator, which is dots 2, 3, 5, 6, the length of the separation line down below. And then we place our carried numbers just as they are in print, above the tens place and above the hundreds place. Phew, okay, now talking about canceled numbers. Those normally show up in subtraction problems. There is an open cancellation indicator and a closing cancellation indicator. Each numeral or set of numerals need to be canceled just as they are in print. Here's a print example: 100 minus 23 equals 77. The digits in the 100 are canceled, the 0 in one's place by itself, and then grouped the 10 in the hundreds and tens place is canceled out together with 10 and 9 above. So in subtraction with canceled numbers, we still need to put that minus sign 1 cell to the left of the widest arrangement. So that sticks out and is not in the way of anything else. The cancellation indicators also need to be aligned. So we can't have digits under those cancellation indicators. That means 23 is spread pretty far apart, as is the answer 77. The separation line again sticks out 1 cell to the left and 1 cell to the right. Then let's take a closer look at the cancellation. So in the ones place, we have 0 canceled out. So we show that with dots 2, 4, 6, then 0, and the cancellation terminator, which is dots 1, 2, 4, 5, 6. We can't put that 3 below any of the cancellation indicators, so that is in the ones place under the 0 being canceled out. Above that is 10, which is 2 digits, and we can't have that 1 in that replace 10. So we need to spread out the cancellation indicators so that the 1 can come straight down and is not interfering with a cancellation indicator. Then our other cancellation indicator, it encloses 10, which is being, or 10 rather, I should say, which is being canceled out together. So again, we have our cancellation indicators opening and closing. The 10 is 2 digits, so the 2 in 23 needs to be below the ones place in 10. It cannot be below any of the canceled indicators. The 9 replacing 10 is above the cancellation indicators, above the number being canceled rather. So you can see that you can take the finger all the way down the ones place and all the way down with the canceled indicator in the tens place, 0, 2, and 7. Multiplication is different with spatial arrangements. The symbols comprising the multiplier and the multiplicand are aligned as in print. The multiplication symbol, if present, is placed immediately to the left of the multiplier, so it does not need to be sticking out to the left. The separation line still is 1 cell longer on either end than the overall arrangement. So here's an example in print: 123 times, well, it's a multiplication cross there, 12 equals 246, which is a partial addition, partial product, I think it's called. 246 plus 1,230, there's a comma there with 1,230. And then all of that equals 1,476. So what we really have here is a multiplication spatial problem with a partial product addition spatial problem. So we need to follow the rules of both. Above the first separation line, that's the multiplication problem. So the multiplication sign does not need to be sticking out to the left of any of those numbers. So we can have 123, then the multiplication cross symbol, sign, I think it is actually. See, I get confused. But 12, and then we have our separation line with the partial product 246. Followed by 1, 230. Those two numbers then need to be added, so that becomes an addition spatial problem. Now we need to follow the rules of addition, meaning like aligns under like. If there was a plus sign there in print, that would have to be shown sticking out to the left. And then we have another separation line. Both of those separation lines are the same length. So that's why the first one underneath the multiplication problem sticks out 2 cells to the left and 1 cell to the right, because it has to be the same length as the addition separation line. And our complete answer then is 1,476. Notice that 1's places all align, 10's places all align, 100 places all align, commas align, and 1,000 places align. Our last topic will be division. You align the dividend, which is the number being divided, and partial products as in print. If there is no quotient or partial products or differences, it is not spatial. On this slide, I've shown two different division problems. The first is spatial. 7 is divided into 56. So we have 56 and 7, and all of that is touching the division indicator, which is dots 1, 3, 5. It looks like O, but it isn't. Again, we're not using numeric indicators in spatial arrangements. So we have 7 divided into 56. And we also have a separation line above to separate the division problem from the quotient up above, which is 8. In print, it's above the 6, so in Braille, it is also above the 6. After that division exercise, we have partial product, which is another 56. And that, as in print, is aligned 1's places and 10's places. Another separation line, all the separation lines have to be the same length. And then our final answer of 0. The next example, 7 divided into 56, there are no quotients or partial products or anything like that. So it's just student compute this division problem. That is not spatial. It is use the numeric indicator then because it's not spatial. Show the division symbol, division symbol of dots 1, 3, 5, but there's not going to be a separation line because there is no quotient or addition or subtraction happening. And that concludes part 1. We'll carry on with part 2 in the next installment. Thank you very much for listening.